So there are some.
Ma'am,
Yes. Anybody else?
ma'am, without instruments, you cannot get accurate information about whatever sample you are using.
Okay, so you think that instruments help us to get more information about the sample, correct? Okay, so Ajinkya and Juhi have answered it a little bit, and I'm not now going to simplify it for you. Have you ever heard about these terms like analysis? Have you heard about the term analysis? What is analysis? So this is going to be an interactive class. I don't want somebody, I'm not someone who will keep talking and y'all are just going to listen, nothing like that. It is going to be an interactive class. So because without discussion, it is very difficult to understand these topics. I will just go on talking.
Excuse me, ma'am.
Yeah.
Can I answer?
Yes, please.
Ma'am, these instruments mainly increase the accuracy, or these are less time consumable and more accurate with the observations.
Yes, so these instruments actually speed up the analysis. It's a technique that will speed up something. What will it speed up? Because when we are talking about research, we are using a lot of things. We are mixing them together and we see that whether something is reacting with the other thing to give us something else. Now we say something, so X plus Y reacts and they give you Z. Now what is this Z? What molecular chemistry does it have? What structure do the particles have? So basically, when you talk about instruments, instruments are actually enhancing the rate of your work, because once you know that you have a certain product, now whether that product is of your interest or not, you will decide based on when you identify the product. It is very important in molecular biology, in chemistry, because these are now, see, you are not only biotechnologists, you don't know that whether you are going to stay in this area of work. When you finish your BTech, some people, some of y'all might opt to go for MS, PhD. Some of y'all might want to take up an industry job. Some of y'all want to do MBA and take another route. So y'all don't know where you are going to actually be. But biotech nowadays, research nowadays, science is all about interdisciplinary work. Even if there are instruments that you may not need to use, but you must know about them, because you never know in what area you are going to land in future. So many of these, like CD ho gaya, spectroscopy ho gaya, definitely we use a lot of spectrophotometer in while doing enzymatic assays. I hope you all know what are enzymes, or maybe you all have been introduced to enzyme in one of your units. So enzymatic assays hota hai, usme kya hota hai? We have reactants, right? And then there is an enzyme which acts like a biocatalyst, and then you get a product. Now that product could be XYZ. It could contain something, it could contain amino acids, it could contain some, say, synthetic compounds, it can be of a different color. So now based on the color, you can actually identify what is the composition of it, but just not by seeing it. You just can't see that this is orange color, to isme ye hoga, it is yellow color, to usme wo hoga. Now our eyes don't have the ability to analyze it. So now that's where the role of the spectrophotometer comes into picture here, because now light is a component which is going to help us probe what is the composition of this particular product. Okay, so what we are using light. We are exploiting light here so that the light can tell us that ये जो particular compound है, ये light की presence में कैसे interact कर रहा है. It's an interaction between the light and the matter. Now we all know that everything around us is matter. What is a matter? Because I'm going back to your basics. How do you define matter? How do you define matter?
Ma'am, anything that occupies space and has mass.
Correct. So we are all surrounded by matter, right? Now, is light matter? What do you think? Is light matter?
Light has a dual nature.
Dual nature. Okay.
Yes, ma'am.
Okay. So light has a dual nature, but plainly, I would say light and sound, you can't say that they are matter, basically. Your dreams, your thoughts are not matter, but rest of the things that are having mass and that occupy space, as per the definition goes, yes, they are all matter. Okay. So when we talk about light, now light is not Okay, we have also seen in your class 8, 9, 10, we have studied all of that in science subjects, saying that whatever light you see, whatever white light you see is composed of 7 different colors. We also studied the prism experiments where you saw dispersion of light. So that basic is going to help you to build up on that. Now, when we say light is composed of, it has 3 components. It has ultraviolet radiations, it has visible light, and it has infrared also. So I have some slides here and I'm going to share the slides, but basically I'm someone who will not only stick by slides. I will keep on talking about different things also, and keep scribbling on the screen. So if somebody feels something interesting, note it down or take a screenshot, because I may not be able to retain those notes on the slide, because when I share the slide, I will share just the slides, not whatever I have written on the slides. Okay. So when we talk about interaction of light with the matter, what happens when light falls on a particular matter? What do you think? What happens when, say, light falls on you or light falls on a cupboard? What will happen to the light? What is the property of the light in this case?
It reflects
It
back.
reflects. Very good. And what is the another property of light when it changes medium, when it goes from one medium to the other medium?
It refracts, basically it bends.
Basically, correct. So light can reflect. That's a natural phenomenon. And light can also refract. That is also a natural phenomenon. Now, why is this so important? Because when we are talking about spectrophotometry, what are we going to do? We are going to take our sample in a cuvette. Have you all seen cuvettes? Have you all used spectrophotometer in the laboratory?
Oh, yes, ma'am. I did this
Yes,
practical.
okay, great,
No,
great.
ma'am.
Okay, fine. You all will do it. I mean, you all are doing your BTech definitely in these 4 years. You all are going to definitely use a cuvette. What is a cuvette? It's a fancy name, but you will just say that it's a holder. It's a container basically. Now, at times, cuvettes is made up of plastic. At times, it is made up of quartz. It's like a refined type of glass. And at times, it is also made up of glass. The material of a cuvette is basically plastic, quartz, or glass. Why is a cuvette used? Because this is the place where you are going to keep your sample. Now, this sample can be anything. Okay, this sample can be anything. So, very, very simple, basic idea is you have a source of light. This source of light is going to pass through your sample. Okay, now light falls. What is this all? Nothing but matter. So light is going to fall. There are going to be some particles here. Light is going to fall on the matter. Because of the light falling on the matter, there are going to be certain changes. There is going to be a certain interaction. I would use the word interaction. Interaction between whom? Interaction between the light and matter. Between light and matter. And this is going to give you a certain reading on the spectrophotometer. This is like a simple pathway that happens. That is how the spectrophotometer works. Now, this reading is going to help you analyze something. ये मैटर जो है इसके अंदर, ये जो मॉलिक्यूल है या जो भी पार्टिकल है वो क्या है, it is going to tell you more information about that. But before that, I was asking you I was telling you about some terms. Now, when you talk about, say, we talk about analysis. What do you mean by analysis? See, we are talking about analysis because we are doing biochemistry here. We are interested in biochemistry. We are interested in chemistry. So you have to estimate. Analysis is estimation, I would say. Just if I have to answer in one word, I would say analysis is estimation. There are 2 types of analysis now. Have you heard about qualitative and quantitative analysis?
Yes, ma'am.
Yes. Correct. So what do you mean by qualitative? See, suppose I am going to an art gallery and I am seeing a lot of pictures. I see pictures and I will start analyzing those pictures. What will I say? Oh, it is made on canvas. It is made on a paper. It's an acid-free paper. It is a thick paper. It is a thin paper. Look at the colors, acrylic colors, watercolors, oil colors, whatever it is. I am not a great person in to talk about art. I like to see, but I don't know how to paint, so I don't have much information. But yes, this is qualitative analysis. Where you talk about the quality, you buy certain thing, you are judging the quality. हाँ, इसका कपड़ा अच्छा है, इसका print अच्छा है, whatever it is. Okay. Now, what is quantitative? When it comes to numbers, then it becomes quantitative. Okay. When it just comes to say texture, or it comes to type, or whatever visionary aspect, when you see something, you talk about it, that is quality. This is quantitative. So in biochemistry, in chemistry in general, you will see that there are two types, qualitative and quantitative. So qualitative is just giving you some sort of a surface idea of particular thing. मतलब कि अगर मुझे किसी ने बताया कि A प्लस B को जब मैं मिक्स करूंगी तो मुझे C मिलेगा, और ये जो C है ये ब्लू कलर का होगा, हाँ, तो फिर what I will do, I am just going to mix them. If I get a blue color thing, I will say, okay, I have got C. Now that is my qualitative analysis, because I am only seeing the color. But if somebody says to me that you will get, say, 2.5 units of enzyme activity, okay, when you see a particular blue color, and if that blue color reads to, on the spectrophotometer, if it reads to point, say something 0.632 or something like that, which will tell me that how much is the enzyme activity, it is 2.5 unit enzyme activity. So it means now it is talking about numbers. So we are talking about quantitative analysis. So quantitative analysis is very important. Why is it important? Because biochemistry and chemistry is nothing without concentration. You know the law of conservation of mass. I hope everybody knows the law of conservation of mass. Yes?
Yes, ma'am.
Yes. So how important is law of conservation of mass? It's extremely important. Why is it important? Because we have also studied this in your school, that when, say, X, okay, there are reactants. Now reactants, both reactants will react to give you a product. So suppose you have reactants X plus Y and you get a product Z. Now your X is 1.5 gram, your Y is 1.5 gram. So what will be your product? What will be the mass of your product?
3 grams.
3 gram. What does this tell me? This tell me that law of conservation of mass is followed by every chemical reaction outside the laboratory, that is in nature. And that's why in the laboratory also we follow the same law, where we are taking some reactants, we are getting some product, but the mass of the reactant is equal to the mass of the product. Okay, so now here we are talking about quantity here. Okay, now some things like in chemistry can be analyzed with by different techniques. So say first is, say, visual. You see something, color change हो गया है, हाँ, इसका मतलब है कुछ तो केमिकल रिएक्शन हो गया है, बट उस कलर चेंज को हाउ आर यू गोइंग टू डिटरमाइन, और हाउ आर यू गोइंग टू डिटेक्ट द कंसंट्रेशन? फॉर दैट नाउ यू नीड टू डू क्वांटिटेटिव एनालिसिस. सो क्वांटिटेटिव एनालिसिस के लिए यू हैव स्पेक्ट्रोफोटोमीटर, you have CD, which is known as circular dichroism. I think I have a slide here which talks about a lot of things. Yeah, so you have HPLC. Have you heard about HPLC? Have you heard about HPLC technique?
No, ma'am.
No. This is a high pressure liquid chromatography. We are also going to see chromatography in one of the chapters. So see, there are different types of quantitative analysis where you can actually find out the concentration of your particular compound, which is of your interest. Okay, so now that was one thing that I wanted to discuss. I'm first going to discuss a lot of basics, like what is plane of polarized light and all that, because spectrophotometry mein ye sab cheeze important hai. Circular dichroism that we are going to study, you need to really understand what is wavelength, what is this, what is that, because without that we can't go ahead. Okay, and if I keep on teaching like that, then I think then you all will have to also do a lot of self-study. So please refer. So this is the reference book that we are going to use for this chapter. So please note down, this is there in your library also. I got a ebook from your ma'am, the librarian. So you all can also refer to this book. So can I move the slide? Have you noted it down? Have you?
Ma'am, could you please mail us the ebook copy if you have?
I wait. Let me see. Or maybe y'all can ask your ma'am there, the librarian, if she could mail you the ebook, because there I feel y'all should go to the library and refer to the hard book. Ebook is great, but still go and refer to the hard copy also. See how it looks. Feel how heavy it is. Okay, do that.
Okay, ma'am.
Okay, so now there are certain, again, there's one more, something like absorption, another term. Okay, we know that when light falls on a certain object, depending upon the nature of the material, depending upon the nature of the object, it may absorb light, it may reflect light, or it may allow the light to pass through it. So based on that, we also identify the matter as opaque, translucent, or transparent. Opaque is us, basically, the ones who reflect light. Transparent is a window shield which is made up of glass, where the light can easily pass through the window shield. Okay, and translucent is basically something which is semi-transparent kind of a thing. So now absorption, some of the molecules absorb light, some of the molecules emit light. So this is another term that is associated with light: absorption of light, emission of light. Okay, reflection, or I would say reflection ho gaya, dispersion ho gaya. Okay, some objects also do that. So when light falls on a molecule or light falls on a material, the light is also scattering. I would use the word scattering here. So light also scatters. So what are we doing in spectroscopy? We are also using all these processes or phenomenon like absorption, emission, scattering. We are going to use all of that and then interpret the structure of the material that is there to be analyzed. Okay, why is the structure so important? It is very important because we need to know whether your sample has amino acids, whether your sample has sugars, or whether your sample has some different types of synthetic chemicals. ये हमें कब पता चलेगा? जब हमें उसका absorption, emission, scattering, whatever it is, that we get to know. After that, we will be able to tell कि इसमें ये होगा. Okay, so now one of the most important and exciting advances of modern biochemistry. We are talking about modern biochemistry because this phase or this era of biochemistry has developed so much only because of discovery or making of these sophisticated instruments. Without these instruments, biochemistry, where it has come now, would have not come. Okay, so that's why we call it as modern biochemistry. And this sort of modern biochemistry is based on application studies. So fundamental biochemistry बहुत पहले हो चुका था, 17th, 16th century में, 18th century में बहुत ज़्यादा fundamental, everything was fundamental at that time. So that was the beginning where they paved a way for the other people to come and take that further. So fundamental is now applied. We are applying all the principles, we are applying all what was studied before. That's why we call this as an applied bio chemistry, or we call it as applied. So biotechnology is nothing but applied. It's a lot of applications, right? So it's a technique application. So that's why we say biotechnology. So application of spectroscopic methods. So this aspect is very, very important. Now, why? Because when you use the spectroscopic methods, what you can study is absorption, because you're using light as one of the components there. The light enters into the matter and then measure the absorption and emission of energy of different frequencies by the matter, or you can also say that the molecules that are present in the matter. Okay, so any doubt in this so far, whatever I have discussed? Any doubt?
No, ma'am.
No, yeah, if there is, please let me know. I can go back. So today's class is going to be a little slow. Not every day is going to be like this. So with on Wednesday, you will see that things are going to move a little faster. So I may not spend so much time on discussing the basics. So today I'm trying to do that so that it's the first class and I should not go like a express. But I expect you all to also read and come. So now that you know which book I am referring to, please kindly take that book, the ebook or whatever it is, and read it. At least whatever part we are covering, please read that part. So because now our material or our matter or our sample, because we are dealing with bio aspect of it, we are dealing with the biochemistry, the biotechnology. So we are always talking about the bio components. So what are the bio components? We know amino acids, proteins. So our material that we are going to analyze in the spectrophotometer may contain amino acid, proteins, nucleic acids like DNA, RNA, okay, sugars, it could be sugars also, natural sugars, okay, and other biomolecules. Now, these things are the main interest. These are the interest. This is the material that we are going to analyze, and this is going to interact with the light. So when the light falls on amino acids, when the light falls on proteins, when the light falls on the nucleic acids, sugars and biomolecules, it will behave differently. Why? Because amino acids ka chemistry alag hai, nucleic acids ka chemistry alag hai, sugars ka chemistry alag hai. You know, amino acids will contain nitrogen as N as one of the amino group was basically. You will see sugars are carbohydrates. So see, the chemistry is different, the structure is different. So when the light will fall on those particular molecules, light will also behave differently, okay, and that is going to help us to analyze what is there in your compound. Now another one more basic concept that I'm going to talk about is a little bit about light, that how light is electromagnetic. What is plane polarized light? Do you know what is plane polarized light? Have you all studied it in your 11th and 12th in physics? Have you all done that, or have you all anytime read it like out of interest?
Yes, ma'am, a little.
Okay, would you like to tell me the definition if you remember of what is plane polarized light?
No, ma'am, we were not, I mean, I was not taught what plane polarized light is really. We are just taught it is used to determine the optical activity of compounds, whether it is levorotatory or dextrorotatory.
Yes, correct. So levo and dextro is there because I told you that there are some compounds which exist in two forms. Okay, levo and dextro. Dextro is right, levo is left. So that was all discovered by Pasteur and his colleagues at that time. So let us now see what does light do and what is actually the basic principle of, say, spectrophotometer. What does it do? What is the application? All of that. So now when we talk about light, it is an electromagnetic wave. So it will have two components. Light will have two components. The first component is the electric component, and the second component of light is the magnetic component. Okay, there are two components. Now, when you talk about the magnetic component is vertical component. I'm going to draw the diagram also so you'll understand. The electric component is the horizontal component. What is the speed of light?
3
3
to
3 into 10 to the
10
power
raised
8.
to 8 meters per second.
Very good. Now let us consider. We know that we also know that electromagnetic wave है, हम इसे transverse wave भी कहते हैं. We also call it as a transverse wave. Okay. So let us say. Okay. Now.
Ma'am, polarization can be explained as cancelling out vibrations in the
Yes.
either
Yes.
plane
Yes. Yes.
or
Canceling
the
out.
axis.
Correct. Yeah. So we are coming to that. Exactly. Yeah. Okay, so you will see now that The red one is the horizontal one, okay, which is the electric component. And the black one is a vertical one, which is the magnetic component. Is it clear? So now, if you look at this, if I draw and say this is the magnetic field, this is perpendicular, okay. Again, this is the electric component. This is also perpendicular. And if you look at this, so they all three are perpendicular to each other. So what is this? Basically, this is the direction, this is the speed of traveling of light, light wave. This is the electric component of the light, and this is the perpendicular component, magnetic component of light. All of them are perpendicular to each other, and this is how normal light is. Okay, this is how normal light is. How many dimensions are there in this? Can you tell me? How many dimensions are there in this particular? Look at the arrows and
3.
3 dimensions. So the normal light is 3-dimensional light. Okay, so you will say this could be your x-axis, this could be your y-axis, and this could be your z-axis. So this is a 3D light basically. Now, if you want to convert the 3D, say, into 2D, so as some, I don't know, I forgot, somebody told me that cancelling out. Yes, what are we doing? We are converting a 3D into 2D. Okay, but how do we do that? Now there is something which is known as a Polaroid. Have you heard about a Polaroid or read about a Polaroid somewhere? Suppose.
Yes, ma'am. It is an instrument used for polarization.
Correct. So suppose
Yes,
now
yes.
this is my Polaroid here. Okay, इसके अंदर होगा हमारा substance. It's a prism basically, nickel prism. So what is a Polaroid? Polaroid is a substance which will now, so suppose this light, your 3D light I have drawn here, it passes through this Polaroid. It will change. How will it change? Now when this 3D light is passing through this nickel prism, only one component, see there are two components. One is a vertical component, one is a horizontal component. When it passes through the nickel prism, only one component is allowed and the other is not allowed. Okay, now which is not allowed? The horizontal is not allowed, but the vertical is allowed to go. So you have the vertical. Okay, now if you have the vertical, what does it tell you? So this tells you that now this is your magnetic field or magnetic component, sorry, and you have speed, okay, or direction of light that is on this way. So now how many components are remaining after it passes through the Polaroid?
2.
Only 2. So now it is converted from 3D to 2D. So this is only possible because you have used a Polaroid. So Polaroid is a substance. When light passes through Polaroid, normal light, which is a 3-dimensional component, when it passes through the Polaroid, it becomes a 2-dimensional component. Okay, and this is now your plane of, or this process particularly is called as polarization of light. Okay, the phenomenon of converting 3D to 2D light is called as polarization. The 2D light is the polarized light basically. Now what are the applications? What is the requirement of converting 3D into 2D? I mean, everything is fine. Why do you want to convert it? Because there are certain applications, there is certain technology which has come into the modern era where this is a very good application. See, where do you find? So there are certain sunglasses. There is something which is known as LCD. You know what is LCD?
Yes, ma'am. Liquid crystal display.
Yes, display. Correct. So what do they do now? There are certain sunglasses where the vision is better. the better vision. So there is like this, you wear it to protect your eyes from the light which is there outside. So when that light passes through the glass, the person actually is able to see better. So better vision is the most important application. Initially there were televisions, I don't know if you all have ever seen those kind of televisions, but in my childhood we had those bulging out glass wala television, and now it is all LED, LCD displays. So why? Because in LCD there is this layer on the screen, and those layers are the liquid crystals, and these liquid crystals act like a Polaroid. So basically they convert 3D into 2D. So that is why the picture clarity has suddenly become very important. Much the clarity, higher is the price of that particular device. So this 3D is converted into 2D, and hence you can see a better high resolution, high definition, or whatever it is. So that is the application there. Okay. So I'm just going to dictate a small paragraph. Anybody wants to write it down, please write it down. Light generates an electric field perpendicular to the direction of propagation. Light generates an electric field perpendicular to the direction of propagation. In regular light, the electric field could vibrate. The electric field could vibrate on an infinite number of planes. Could vibrate on an infinite number of planes. Full stop. Plane polarized light is the light in which electrical field vibrates, only on one plane. Only on one plane. Okay, done everybody? You all have written it?
Yes, ma'am.
Okay, so now I'm going to talk about a little, this amino acids ke bare mein. Because basically in biochemistry, when we use spectrophotometer, basically it's related to amino acids, related to say proteins, all of that, enzymatic acids basically. उसमें हम spectrophotometry का बहुत use करते हैं. Circular dichroism also is, you all know about the structure of protein, like just a little basic, that there is primary, every protein has a primary, secondary, tertiary, and quaternary structure. Have you all read about it?
Yes, ma'am, in chemistry.
In chemistry, okay. So when you use circular dichroism, you are basically elucidating the structure of the protein. You can tell कि ये उसके रीडिंग का जो एनालिसिस होता है सर्कुलर डाइक्रोइज्म में, you put your protein into a cuvette, you put it into the circular dichroism, and then the light passes and you get a certain reading there. When you get a reading, you can actually tell whether the protein is in primary state or in a secondary state or tertiary or quaternary. So that is what we talk about structure. So that's why I'm going to a lot of basic stuff, so you all can understand the difference between spectroscopy and circular dichroism. So there are certain amino acids like phenylalanine, then tyrosine, tryptophan. Now these, as I told you, that light में सिर्फ light ही ऐसा component नहीं है जिसमें हमें सिर्फ visible range है. Light has a broad range, and that range is divided into 3 parts. So UV, visible, and infrared. Okay, I think I have a slide here which is not very clear, but Yeah, so this is how it is. See, so this part is the UV, then this becomes the visible, and then this becomes the infrared part. So when you look at the wavelengths, so wavelength range of a UV visible light, so in this band you will see something like this, shorter wavelengths. This is visible. Here you will see longer. What is the wavelength, the distance between the two peaks? If you look at this is short, but this is long. Okay, now UV light hota hai, the wavelength of the UV light is between 180 to 350. Wavelength range of visible light is between 350 to 800. Wavelength range of, I think that should be infrared actually. Okay, so infrared falls in this category, which is basically after 600 to 700. So uske aage jo bhi hoga wo infrared hoga. So now when you talk about the visible spectrum, which is this, which is the light that we see outside, the visible one, okay, it is mixed. Ultraviolet is also there, but again it depends on which time of the day you are talking, whether at the sunrise, sunset, afternoon. So at those times the UV rays are more concentrated. But the visible range that we want to talk about, when that visible light passes through a prism, the white light that we have, when it passes through the prism, it diffracts, and then you will see that it refracts, and you will see that dispersion hota hai usme 7 colors mein. So now every color has a wavelength. So now if you have your product, you did a reaction and then you get a violet color product. Now that violet color is what you don't know. So what will you do? That violet color is going to resonate. The wavelength of that violet color substance is say 400 to 420 nanometer. When you put it in the spectrophotometer, you will have to set the range of the spectrophotometer in this. Because why? Because violet color ka jo wavelength hai wo itna hai. So if your product is of violet color, you can only read the product, you can only analyze the product at this wavelength, not say at 440, 490 or nothing like that. Why? Because those particles will not resonate at a different wavelength. So every color has its own wavelength, a very specific wavelength. Look at the range. Violet is 400 to 420, indigo is 420 to 440. So every color is having a different range. That is why when you have a product of some which needs to be analyzed is of a different color, you will have to change the filter also of a spectrophotometer. Okay, so we will go into the details as and when. Now I'm talking about certain amino acids. The amino acids are phenylalanine, tyrosine, tryptophan, all of these. So you know amino acids constitute to make a protein. So if you look at a pearl necklace, each pearl is like an amino acid. All the pearls are amino acids. They come together and they make a protein. Okay, there are 20 amino acids or more than that or less than that. Can somebody tell me how many amino acids are there?
20, ma'am.
21.
Correct. So now in the modern biochemistry, the structure of these amino acids have been determined with the help of the property of their interaction with light by the help of spectroscopic measurements. Okay, why? Because when you talk about amino acids, there is no amino acid, none of the amino acids absorb light. None of the amino acids absorb light. Okay, which light are we talking about? We are talking about visible light. What is the visible light range? It is somewhere between 400 to 700. So agar nanometer. Okay, if your spectrophotometer, if you actually pass a light between this range on amino acids, they are not going to absorb it, but they only absorb UV, only absorb UV light. Okay, so that is why you have to read. If you have a sample which is containing of amino acids, you put it in the spectrophotometer, you have to enter manually the conditions in which you want to read. You have to set the parameters also. So you have to know what you are reading. So you put, if you have amino acids wala product in your cuvette, you put the cuvette inside, set ki amino acids hai, so you have to read it in the UV range only. Set to a UV range and then take the reading. If you read amino acids at visible light, or if you read amino acids at infrared, you are not going to get the reading at all because they do not absorb. And what is spectrophotometry? Spectrophotometry works on the principle of absorption and emission of light and scattering of light. So if your particular compound is not going to absorb light, then how are you going to get the further details? Also, because if you all have understood the basic structure of, say, atoms. I'm going to atom because everything is a matter. So yes, if my even if I have an amino acid solution, that is also a matter, right? So now if I have, say, these electrons which are there in the outermost shell, this is your nucleus. Now if a particular light wave comes of a particular frequency, comes and hits on this, what is going to happen? Light is a form of energy. Okay, so it will come and it will hit on this. We know that there are certain components which are unstable components or which have a lot of energy. There are some components which are stable components where they don't have high energy. When a certain element has a higher energy, it becomes unstable. When a certain element has an optimum energy, it is stable. Okay, so now if light comes and hits this particular electron, okay, so what is going to happen? The energy is going to transfer into this electron, and now this electron is going to absorb the light energy. After absorbing the light energy, it will become high. The Ke, the kinetic energy, is going to become very high. Okay, once it becomes very high, see, in the total universe, all the matter wants to be stable. They don't enough, nobody wants to be of high energy. Even if you have, say, uranium or any other higher metal which keep on giving radiations, they want to achieve stability. So this electron or this particular element, when it absorbs this high energy, what will happen? It will try to come to a ground state, and while coming to a ground state, it has absorbed, say, red light, and it will emit a different light of a different frequency. Okay, that is the reason why that particular compound will appear to be of that color. Okay, so this is basically what light does. Light actually interacts with the material, and then because it's a form of energy, it gives that energy to that particular material. The material will become high. If it absorbs energy, it will go on a higher state. If it emits energy, it will come down. Okay, is there any doubt here so far?
No, ma'am.
Okay, so great. Okay, let us now move to some other slides here. So what is basically spectrophotometry or spectroscopy? It's the study of the interaction between matter and radiated energy. As I told you, light is a form of energy. So yes, whatever light is falling, basically energy is falling on that particular material. So spectroscopy originated through the study of visible light dispersed according to its wavelength. We know that light is made up of 7 different colors. Which is the shortest wavelength? Which color has the shortest wavelength? Any idea? And which has the longest wavelength?
Ma'am, violet? No, red. Red.
Red has the shortest, or blue and violet has the shortest?
Violet.
Violet has the shortest, red has
Huh.
the longest.
Red has the longest. So what will happen? Longest is the wavelength. Shorter is, so okay. Do you know that why are the signals red in color? Like, why is that one signal which is so important to stop is red in color? Why could there not be any other color chosen than red color? Any idea?
Ma'am, because red has a greater wavelength, so it can be seen easily from distant places.
And it doesn't get scattered easily.
Exactly. Yes, because of the highest wavelength, red does not scatter. If something scatter, it will easily diffuse also, and it will not be seen very clearly. So see, red is that color which is associated to danger, because when you are even far away and if you see some red light, you know that maybe that's a signal light, or it is indicating danger. That is how red color was designed, designated as the color for indicating danger, and green is like basically peace color. So basically all these, this is all wavelength, this is all frequency. So spectroscopy also works on frequency. Okay, because we know visible light has 7 different colors. UV does not have 7 different colors. UV is a different spectrum. Wavelength, visible light has 7 different colors. Every color has its wavelength, and when that color falls on a particular particle, when that color falls on a particular matter, it will also transmit that energy to that particular particle. Okay, that is what is basically interaction between matter and the radiated energy. Now that radiated energy could be UV, it could be visible, it could be infrared. If you're working with amino acids, certainly you are going to use UV only, because we now know that amino acids do not absorb visible light. Okay, so later the concept was expanded greatly to compromise any interaction with radiative energy as a function of its wavelength or frequency. Yes, because certain frequency, wavelength and frequency are connected to each other. This is a lot of physics which is very basic when you had sound waves in your science. So maybe a little revision of that could help. Okay, it's a technique now that is used to assess the concentration. Now when you talk about concentration, this is where I was talking about quantitative analysis, or amount of a given chemical, atomic, molecular, ionic, whatever chemical species is, because spectroscopy is not only used in biochemistry, it is also used in chemistry. So there are 2 types of reactions, biomediated reactions or biocatalytic reactions, and chemical catalytic reactions. So in both the analysis, you can use spectroscopy there. So in this case, the instrument that performs such measurement is called as spectrometer, spectrophotometer, or spectrograph. It's often used in physical and analytical chemistry for the identification of substances through the spectrum emitted from or absorbed by them. So here it is not only physical and analytical chemistry, we also use it in biochemistry. Okay. So again, a similar slide here. So please revise the concepts of frequency, what is wavelength, okay, hertz, what are hertz, wavelength is denoted by lambda. So ये जो है थोड़ा सा revise करना, maybe not really coming in with an examination point of view, but with for a better understanding basically of the subject. Okay, so ultraviolet visible spectroscopy is there. So when you have a spectrophotometer जिसमें लिखा है UV vis spectrophotometer, have you ever read ऐसा लिखा होता है UV vis? Have you seen any time on a spectrophotometer? No. So it means that this particular spectrophotometer can be used, this particular spectrophotometer has 2 sources, okay, or 2 bulbs inside. One bulb is the UV bulb and the other bulb is the visible bulb. So the UV bulb is responsible for emitting UV radiations. You all have used the laminar airflow. Everybody, I'm sure, must have seen the laminar airflow.
Yes, ma'am.
Yes. So in the laminar airflow, you see that long tube, which is bluish in color, which is a UV tube. All of y'all have noted it?
Yes, ma'am.
Yes. So similarly, in the spectrophotometer also, there is a bulb, there is a source of light, which is also of similar color. So that is your UV source, okay? And visible source is a different source, which is a non-UV source. So just if you see a spectrophotometer and which is written as UV vis spectrophotometer, it means it can give you both UV light also and visible light also. So you can read amino acids, nucleic acids like DNA. DNA का concentration भी UV range में ही आता है. So if you are preparing a DNA sample, if you extract a DNA from a bacteria or from a plant, and now you want to know the concentration of DNA, you have a nano drop also nowadays in the laboratories. I don't know whether DY Patil में है कि नहीं nano drop. All you have to do is just put a drop of your DNA sample and put the probe on it, and you will immediately get the concentration. Or else what you do is you take it in a cuvette and put the cuvette in the spectrophotometer, let the UV rays pass through the cuvette at 260 nanometers. Now 260 nanometer is anything from 180 to 400 is UV range. Okay, so 260 is lying in between. So your nucleic acid, matlab DNA sample can also be read at 260. Amino acids can also be read in the UV sample. There are certain things which are colored. Okay, so see, you do a reaction, you do an enzymatic reaction and you get a yellow color substance, or you get a blue color substance, or you get a green color substance. Now that falls in the visible range. So you're going to use the visible bulb. Okay, UV के लिए you use a quartz QH. Okay, it's a refined material, quartz QH. Visible के लिए you can use glass or plastic QH. Okay, so I have a video here for you. I would like to see that.
Brief introduction to spectroscopy. We know that electromagnetic radiations carry energy in waves. So when these energy-carrying waves strike any material particle, they produce some change in the particle. The study of the
Excuse me, ma'am.
interaction between electromagnetic.
Yes.
Only the voiceover is heard, not the video is not being displayed.
Oh, is there a problem? Can you see this like this, like now, if I minimize it?
No, ma'am.
No, what do I do? Should I share the link and y'all can see it later then?
Yes, ma'am.
Yes.
Okay. Okay, at least listen to this, because first listen to it and then y'all can see it on your phone later on, but just listen to it.
Magnetic radiation and matter is called particle. Give a brief introduction to spectroscopy. We know that electromagnetic radiations carry energy in waves. So when these energy-carrying waves strike any material particle, they produce some change in the particle. The study of the effects of interaction between electromagnetic radiation and matter is called spectroscopy. Thus, spectroscopy is the study of interaction of electromagnetic radiation with matter. There are two ways in which the interaction between electromagnetic radiation and matter can take place: by absorption and by emission. Let's first discuss about absorption. When the electrons present in atoms or molecules of the matter absorb energy from electromagnetic radiation falling on it, they jump from ground state to excited state. This phenomenon is called absorption. Now let's discuss about emission. When the atoms or molecules present in the matter jump from excited state to the ground state, they release electromagnetic radiation. This is called.
So basically, when any form of energy falls on the electron, whether it is a light energy or whether it is a sound energy. So when anything falls on an electron, if the electron absorbs energy, obviously its kinetic energy is going to increase, and from a ground state, it will go to an excited state. So on absorption, it goes from ground to excited. Now, when it is in the excited state and when it will emit energy, that is emission of energy, it will come down to the ground state. So from excited to ground. So when it also emits light, when it goes from ground to excited, it also emits light when it comes from excited to ground.
Called emission. Spectroscopy is extensively used to study the internal structure of matter, especially molecules of complex organic or inorganic compounds. Some of the major advantages of using spectroscopy over trivial methods of structural determination of complex compounds are: it is a very less time consuming. The amount of sample required is very less. Although the setup cost of spectroscopy is high, but it's very cost effective in long run. Note that in both absorption and emission, the energy of electromagnetic radiation absorbed or released is equal to the difference between the energy of the excited and ground states. The related terms are
Yeah. Any doubts so far? Yes.
No, ma'am.
Okay. So I'm just going to ask you some questions. Please answer in the chat box. Will you all do that? Based on whatever
Yes, ma'am.
based on whatever we did today. Okay, whatever I have explained today, based on that. So true or false? Light is an electromagnetic wave. True or false? Light is an electromagnetic wave. Yeah. Okay. The phenomenon of converting 2D to 3D is polarization. Listen to the question. The phenomenon of converting 2D to 3D. I'm not saying 3D to 2D. Okay. Yeah, it's false. What is polarization? You minimize one component. You take away one component. So 3D से 2D हो जाता है. ठीक है? Amino acids absorb ultraviolet rays. True or false? Yes. Yeah. One application that we discussed today, mention one application where polarization finds an application. Polarization of light. Yes. Correct. Is spectrophotometry a quantitative analysis? Is spectrophotometry a quantitative analysis? Yes or no? No. No. Is it no? I am asking, is spectrophotometry a quantitative analysis? It is a quantitative analysis. That is what we discussed. See, we can also determine the concentration of the substance. Okay, we can also determine the concentration of the substance. So that's why it is a quantitative analysis. Any doubts, anybody? Okay, great. What else did we discuss in this? I also gave you a definition of polarization, right? What is so what are the two components of light? What are the two components of light?
Reflection, refract and reflect.
No, those are the properties. I'm asking you the components of light, electric and magnetic. Correct.
अपना LMS अभी तक अपडेट ही नहीं हुआ.
Pardon? Okay, electric and magnetic. Yes. Okay, you all can ask. So you all can ask me any doubts that you have, like other things, like if you want to discuss, because I'm going to stop here today. We have done enough of theory. So we still have 10 minutes. If you have anything else to discuss, please ask me. So if you all, do you all know any other techniques other than spectroscopy? Like, have you all ever heard about NMR? Have you all heard about NMR?
No, ma'am.
Okay, NMR is a nuclear magnetic resonance. See, we are talking, it's also a spectroscopic technique, but it is a little sophisticated than spectroscopy. Spectroscopy fits in, spectrophotometer you can fit in any corner of the lab. Okay, on a table, in your house also you can do that. But NMR ke liye, NMR is a huge setup. You need a special room for NMR. That also is a spectroscopic technique, and it involves absorption of radio frequency energy. So these techniques are working on some form of the energy. So in spectroscopy, you are using light as a form of energy. In nuclear magnetic resonance, you are using a radio frequency. So that particular radio frequency will go and hit on the matter. The matter will also start resonating with that. So in that, the matter will either get excited, or it will also so it will give it will take the energy, or either it will come down to the ground state, it will emit energy. So that is what basically you are trying to use to know the structure. Okay, so that's why I told you that, and also know the structure and know the concentration of the structure. So NMR basically works on the structure elucidation. When we talk about spectroscopy, we are talking about quantity also, we are talking about concentration also. So that is one of the applications. Now regarding how are we going to, so I was thinking that I could give you some test or something, not now immediately. Definitely there can be some there is an assignment component also. So what do the other teachers give for assignments? I would just like to know.
Ma'am, any sort of questionnaire if you want us to solve, and or
Le-
either any topic which you need to elaborate on.
Yadnya ma'am gives us MCQs on LMS.
Huh?
So basically, like one chapter, and she will give a time limited LMS MCQ quiz. Like
Okay.
we have to solve it within 1 day or 2-3 days.
Okay. Okay. So do you also want the same for, I don't know what can I give you, because on yes, yeah, does Yadnya ma'am take online classes or she takes offline? I think she takes offline, you know.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
She had taken online before though.
Okay, fine. So I will also do something like that. We don't have any assignment as of now, which is due as of now, but I just thought of taking an idea. So probably I will also end up doing the same, where I can give you a test, something, or maybe ask you to write something on some topic, something like that. Okay. So you know what is the reference book for this particular chapter? Please refer to that book. Try to read as much as you can. It's a big chapter, and there also they have discussed about absorption, delta E, matlab the difference between the absorption energy and the emission energy, that is delta E. They have gone into a lot of details. Please read that, because I may not able to discuss all of that in the class. We have a lot of things to finish and we have limited time. So I will not be able to go into that much detail. But if you read the textbook, if you read the chapter, it will help you to understand, because I may, jump from one point to the other point. So wo samajh mein aayega ki what is happening. Otherwise you will be clueless. So for the next class, like which is on Wednesday, I hope, I expect you all to read, and I will probably share. I got an email from your librarian of 2 books. So I will forward that email to Akshata and Juhi, and you all will circulate that to your class then. Okay?
Yes, ma'am.
Okay. So should we stop then? Okay. Another thing is, I wanted to know that, do you know anything about stereochemistry? Have you heard about stereochemistry?
Yes, ma'am.
Yes,
What?
Yes,
ma'am.
ma'am.
Okay. What do you understand about it?
Ma'am, chemistry of structure of molecules.
Okay. So do you know that there are certain compounds which exist in 2 different forms, out of which one of the form is active and one of the form is inactive? So for example,
Yes, ma'am.
yeah. So do sugars exist in levo and dextro, or amino acids exist in levo and dextro?
Ma'am, sugar.
Sugar exists
Sugars.
in both.
But there are also L amino acids and D amino acids also. Do you know there are L amino acids and D amino acids also? So till the next class, I would want you all to read about, can you use spectroscopy to find out the different structures? Whether, say for example, there is glucose. So there is L glucose and there is D glucose also. So how will you identify? If I give you 2 solutions and I ask you of glucose only, and I ask you that solution A and solution B, please find out whether solution A is L or solution B is L. How will you find it out? Can spectroscopy help you? So basically your keywords are going to be spectroscopy, optically active or optically inactive, determination, something like that, and just find out a little bit about it. It could be just simple yes or no. No ma'am, we cannot use spectroscopy for identifying the optically active or optically inactive stereoisomers. You all can tell me like that. So I just want you to spend another 10 minutes any time of the day, search about it, and on Wednesday you all can tell me about it. Okay?
Okay, ma'am.
Yeah. Okay then. See you on Wednesday, everybody. It was nice meeting you all. Yes, you all can log off. So I'm done for the day.